This is Advanced Math SBAC Review, Worksheet number 5. This one talks about equivalent equations. We talked about equivalent before, meaning the same value, but maybe not the same appearance. So I'm going to write that down. Equivalent equations may look different but have the same value. Okay, so a simple one from like a linear would be something like if I have x plus y equals 2. An equivalent equation would be if I multiply everything by 3. Okay, so those would be equivalent. They look different, but they are equivalent in value because they did exactly the same thing to both sides. Okay, now here we're going to be focusing more on quadratics, and quadratics can look very, very different. Linears can sometimes have a lot of same structure. Sometimes they do look very different, but quadratics have a lot of valuable uses. Okay, so this first one says that the 3 equivalent equations, these are all the same, they just look different, are shown. Select the form that reveals the zeros of f of x without changing the form of the equation. Okay, I'm going to select B here, and that's because I can see where my graph is going to cross the x-axis. Okay, so let me write that down over here. So for number 1, if I were to try to graph it, I would know right away my 3 and my 9. Remember, I would go set them equal to 0. And then it's negative, so it would do something like this. This is a concept we did a lot in Math 3, and we haven't reviewed as much in the Advanced Math curriculum. Okay? Good, good. And this is called intercept form. And the reason we call it intercept form is because you can see the intercepts. I just do the opposite, just like opposite of h. Okay. Remember too, it says for the 3 equivalent, in number 1, select all values for which f of x equals 0. So I'm going to plug in 0 for my f of x. Okay, now remember they're all equal. So if I were to try to solve this equation, about 24x, I'd have to use factoring or quadratic formula. Okay, for B, I would have 0 equals -2, x minus 3, x minus 9. Okay, here I could do it really easy. I set each factor equal to 0. Okay, and that's how I'm getting those intercepts I had up there. I add my 3, x equals 3. Okay, and that's how I got them. You can do those in your head, I usually do, but when you're taking that SBAC, you want to make sure you double check your reasoning. Sometimes we get overconfident, or sometimes we don't have enough confidence, and it just shakes us up a little bit. Okay, so here I'm going to circle 3 and 9, and it may have something where you just click on them. Okay, or you select them and you drag them to a location. Okay, here, 3 equivalent equations are shown. They're the same ones. It wants to know which one reveals the value of f of x when x equals 0. So this time I'm going to plug in x with 0. Okay, so this is number 2. Okay, so if I plug in 0 for the first one, that would be 0, this would be 0, and voila, I get my negative 54 because that would be 0. So I can see that without actually doing the math, okay? But if I were to do this one, I plug in 0, here I would still have to do math. Like I don't see the answer, which is 54, in my value here. I would have to go, oh, that's negative 3, negative 2 times negative 3 is positive 6. Oh, that's negative 9, negative 6, no, positive 6 times negative 9 gives negative 54. So it's a lot more work. I can't see the answer. So I would not pick that one. Okay, same thing with C. Okay, if I were to plug in, I'd have to do work to figure out my value. Okay, so the answer that we are going to pick is here. Now, how do I know that there's only one? It says select the form. That means one answer. Uh-oh, I looked at the wrong one here. Bam! It was that one. A. One answer. Okay. So here, then it says which one is when we solve for x equals 0. That was negative 54. Okay, this one I accidentally put the answer for number 4 there. Crazy day. Okay, so now it's saying it wants the maximum. And so remember earlier when I did that in that basic sketch? Okay, so one of the forms shows us how to get that, and that would be the one that we've been focusing on for sketching. And so one of these forms, yes, but it's not telling me what that maximum value is up here. Okay, so that one's not so great. But if I look at this other one here with the HK, I'm gonna write that down. Okay, if I were to plot it, that would be 6 and 18. And then I would just know that it's a downward facing U. Okay, so the problem here is I have an 18 and a 6, so which one is my answer? Well, maximum, if we think about it, we know two distances. We know this distance from here to here is 18. We know this distance from the origin from here to here is 6. So which value gives you your maximum? Not the 6. That's telling you how far right the graph is. The maximum or highest point is when the graph is at 18. That was C. Okay. All right. Which equation reveals the minimum without changing it? So I'm going to do the same idea. This one, if I graph it, it's going to be like that, where my 3 and my 1. So that does not tell me the minimum. Okay. This one here, I know that my y-intercept is negative 3, but I don't know anything else. Something like that, maybe. Okay. Oh, but that's not necessarily the lowest point. Okay. Here, oh, it's not even combined like terms, so I don't know what to do with that one. I'd have to do some more work. But this one here, I can see for my A that if I plot that HK, that's 1, negative 4, and it's an upward facing U. Now I can see how I'm getting my minimum or maximum. So that choice is C.